Hello and welcome back to the channel where we are building a video game from scratch using Love2d and Lua. We're working on adding boars to our game. Here's a gecko example where we can cleanse, but we're trying to add boars. And so far we got them animated and imported. We can see that in our, what is it, map declarations? No, it's in our Boar Atlas. Here in dependencies, we have a boar sprite sheet, and then we generate quads based on the boar location size, which is 16 by 16. So we have all of those loaded. Now we're trying to add boars. So how we've been doing that is through our entity system, and we basically just plop entities into the scene, right? We're on a map 7.3 right now, and we're trying to put in a boar. So we say, go ahead, instantiate an entity into this table, go give it the boar animations that we defined in the entity defs, which is what we just saw that we imported right here. And actually, that's actually not here. This is just where the atlas is stored. But what we do is we have a entity defs, which is right here, this boar entity definition, that we define the animations and we say which texture of the global texture we have. So we define the atlas as boar, we set the texture of the animation to boar, then we define which frame it is that is boar. So like walk up is 1, 2, 3, 4, walk left is 8, 9, 10, 11. So we define all those frames and the string name of what it means, and if it's looping, what speed it is, and then that boar texture. So that's what we're doing right here. We're saying boar animations, go into animations, go ahead, give it an X and Y width and height. Let's make it a type boar, right? Let's make it a type down, direction of down. Walk speed's fine for right now, because this is just the first boar. And what we're trying to do is generate the state machine for the boar, right? Because a boar moves differently than a gecko or a bat. So how we do it here, which is not the greatest, is we're cycling through all the entities in our map. And for every entity, we're going to say, okay, well, if it's a gecko, go ahead and give it the gecko animations. And it's like, we have the animations, right? We assign the animations into the entities dot animations. So what we're doing is saying, well, now we're going to take the dot animations and run. See, and this is kind of weird because we're overriding it here. So I think we technically don't need this, because we're saying go into that very entity, which is this entity we're putting. So we're overriding this dot animations right here. We're saying this animations gets, and then we're going to run the method create animations, and we give it the dot animation from our entity def. So we should have our entity def down here, and we should be able to omit it from that initial init. And then we create animations. See, this is weird because we have more than one entity and it's not all a gecko. So right here, we're going to say we table.insert. I'm pretty sure table.insert adds a value to the end. At least I want to say that. I'm not exactly sure. But I think that's how it works. We can try it. So instead of doing, I mean, we can do this. We cycle through every entity if it's corrupted, and we can probably get rid of the corrupted bit. Depending on what that logic is doing. I'm pretty sure it's just rendering purple. It's defining which purple or non-purple atlas, but we're actually changing to a grayscale tinting rendering just to make the damage flash and the splash field more simple to render and more control to render. Because I didn't want to make a separate atlas for all the tinting of colors, right? We'll see. I don't know. But we're going to say if it's a type boar, then let's go into that exact entity that was a boar, and we're going to give it the boar animations, and we'll actually put this back to gecko C, right? Gecko corrupted. That's horrible. But we're going to say if it's a type boar, we want to give it the boar animations, and then we want to do this stuff. Now, for now, I'm kind of curious if we just give it the, basically we're saying, okay, well, we create the animations, so we have all the animations, and we're going to change to the animation that we're facing, right, which we could do based on direction, but we're just saying we start them off as idle down. Then we're going to go into the state machine and instantiate a state machine with 3 different keys. And for right now, we're saying that the key is going to hold the state machine of whatever state, which is, this is how we're inserting it, right? We say function return the state. And the state's being passed the actual entity, and that's what we're assigning into the key. So for right now, we're setting it to idle because we need a boar walk state, we need a boar flee state or whatever, so that we can give it specific boar specific logic. So for right now, I'm saying, yeah, we enter a boar after the gecko, and then if it's a gecko, go ahead and give it the gecko animations. If it's a boar, go ahead and give it the boar animations. So right now, I'm hoping the boar will perform just like a gecko, but look like a boar. Oh, look at him. Okay, we failed on state machine 51. Process AI didn't have it for a type of boar. Okay, so for right now, we could omit this. We could say, you know what, the boar is actually a gecko, but for every gecko for right now, I just want to get it working with boars, and then we can build out the state machine. Then we can pull it out specifically. Boars, and then they transform. Fuck. Okay, we're gonna do it the real way. We're gonna do it the real way. Okay. Okay. Right now, we're just gonna give it the entity idle state because we have that defined. So if it's a boar, which this one's still a gecko. Okay, so that's okay. We're just gonna have an entity idle state. Entity idle waits until it changes to walk, I believe. Let's take a look at what is the entity idle state. And it's just changing to its type dot walk, tack walk. So this is the interesting part of it. I don't think we need this create animations here. I think this is not doing anything for us. A certain amount of time elapses, and then we change the state to something tack walk. So change state is a method that runs on the self entity, and the self entity is what we pass in to the state as a param, and what we're passing in is the actual entity. So we need this, we need boar walk, right, to be, it needs to be like this. It needs to be type tack walk, because that's how we're changing, which is kind of interesting. But also, if you don't know the code, it becomes weird. But for right now, I'm just saying boar walk is actually the gecko walk state. Shouldn't have anything to do with the animations. But it should act like a gecko walk, and I'm hoping it has the animations of a boar. Oh, look at him. He's moving. Oh, he's so cute. Oh, okay. So look, the entity gives us damage, which is great. He's animating, which is great. And he murders us, which is great. Okay, it's interesting to me that he does go to walk, and he goes to walk down, but he doesn't move. He doesn't move. Why does he not move? He should be getting just the walk state, but let's check the gecko walk state here. Just see gecko walk state. We could be asking if we're gecko. Oh, see, look, we're only adding the walk speed if we're gecko. So just for right now, don't do this at home. But we're going to say, or if our entity type is a boar, then we're also going to add the walk speed to our Y and X position so that we can actually move. I just want to see him move. Let's see. Oh, boar. Yes. Yes. That's it. That's it. That's it. That's it. Look at him tracking me like a gecko. Yes. Oh, he's so cute. Let's go. Look at that booty go. Look at that booty go. Look at him. Yes. Get me. Get me. Okay. Let's water his ass. Water his ass. Blast his ass. Okay. He doesn't get the water splash, but he gets the slow to the walk speed, right? He slowed way down when he got splashed. So, oh, and then he sped up. Yes, dude. The boar looks so freaking good. Let's go. So we need to change him to the grayscale so we can handle damage flashing right. But this is so freaking awesome. Okay. Let's do this again. Let's do this again. Real quick. Real quick. Okay, so if we did this correct, he should be idle. Okay, yep. Yep. And then he walks. Yes. Okay. Bro, can he get cleansed? He can't get cleansed. He can't get cleansed. He's invincible. Okay. No, this is great. This is really great. This is really great. This is really great. Okay. Okay. This is huge. Okay, so what we need to do, we need to give it specific things based on, and you know what? Yeah, we basically want to say if we're an entity. See, it's kind of interesting because in the walk state, we're kind of controlling the movement based on its direction. So our AI is just determining which direction it should move. And then we move based on whatever direction at any given moment. So if it's left, we walk left. If it's up, we walk up. So there isn't a way where we're kind of like pausing and stopping and turning. And it's just always like, hey, what direction are you? Whatever direction you are, update with your walk speed in that direction. So we need to decide if that's the right move for our boar or if we want to do something more complex or something different. But for right now, we need to make a boar walk state to get any specific boar logic. And we could, yeah, because it's like, you know, on one hand, it makes sense to put the walk speed positioning into the entity class so that any entity can just say, okay, well, if your entity is faced up, let's walk up. But it's not so simple with the idle. You know, if he's idling up and he hasn't been tracking you yet, you know, some enemies are going to be waiting for you to get close enough, and then some enemies might stop tracking you or keep a distance from you. So some entities might get splashed and flipped, so their direction shouldn't be controlling their movement. All these decisions we have to make. I think for now, let's just give us the boar walk state and give us basic stuff. Let's render our boar. Let's update our positioning based on our walk speed, and we will also potentially change. I don't know. I was going to say potentially change the AI for tracking. We have some basic tracking. It's basically 50-50 chance whether we track via horizontal or vertical movement, which is, you know, the best I could do as a beginner. But we might start learning more about vectors. That's my cue to get programming instead of just yapping, man. Okay, so let's add our Boar walk state. So what we can do here is add a file. What is add a file %? Boar walk state. So if we give us a Boar walk state, we need to do, how do we do it? Boar walk state. Is it includes? What is it? Includes? It's been so long since I watched this. Includes the base state. It's not this. It's not this. Let's see. Class includes. Okay, so class includes. So we need to do it, and we'll just type it out like we remembered it, just for that muscle memory. So we're gonna say class, and we're gonna say includes the base state. Okay. Okay, the next step, we need our 3 main functions. Let me sit up straight. Oh man, I slouch way too much, man. Okay, we're gonna say Boar walk state. We have an init, we know that much. We know we need an update function for the Boar walk state, and that needs to take in delta time. We know we need a render function for the Boar walk state, and that'll handle the rendering. And we're inheriting the base state from the state machine so we can change to it. All the base state is, oh, we have a change. Oh, we have an enter exit method on our state machine, kind of handle the flow. That's all the base state does. I mean, let's just show what it is. Base state, that's all it is. Say give us an init, an enter, an exit, update, all that from our state machine. And let's take a look at the walk state for the gecko. So our walk state has 2 params, an entity and a scene. And do we use the scene anywhere? Self.scene. We don't use the scene anywhere here. So we might not need it because we don't use it in the update logic. For right now, it's just, there's a lot of junk, right? Like we shouldn't have to recreate the animation here on the init. Actually, no, we do have to. Because the idea is if we cleanse and we walk off, we come back, we need to run the create animations method on the entity again so that we can see them. Okay, so for right now, let's just copy the boilerplate from the gecko, but we'll say, well, only if it's type boar. I don't want to have to do this like a boar entity in a walk state. See, the walk state, it shouldn't be in the walk state, it should be in the idle. If we make the decision to always start the enemies in an idle, we should only do this in the idle. For right now, we give them boar, we give them the animation of whatever walk direction they have. We're going to snag the scene. We need to pull from the params here, entity and scene. We have a movement duration timer, state name, collided, and alpha. That's just boilerplate. See, this is the damage flash. This is fine. It wasn't working for the boar, but for right now, let's just say we need to at least update our position in our update. right? So it's just going to be boar. If it's equal to boar here, see, and it's like redundant, right? It's like we're in the boar walk state. So why are we asking if we're a type boar? We don't need to. But we will get to that a little later. Okay, what else are we doing here? We're saying trigger off screen, which is whatever. I don't know what dot off screen is doing. Off screen just stops us from updating the AI, I guess, and stops it from rendering certain things. Like in the map, we cycle through the current entities, and if we're not off screen, let's go ahead and render it. So if we're off screen, we stop rendering it as well. That looks to be like the main point, is just, okay, off screen, let's just not bother rendering. It's whatever, saves us minimal, but might as well keep it. Okay. If we're off screen, stop rendering. That'll be here. This should probably be in the entity class, not the state machine, right? Because it doesn't really matter if we're in attack state, or walk state is really pursue state where they're tracking the player, but then there's a cleanse or a flee state where they're cleansed and then they run away. But we might want different stuff for different entities. For right now, let's just say we get the type, we modify the positioning, and then we go to render, which we need a process AI. We absolutely need. So our process AI actually requires, and this makes sense, but it requires, so we call this Boar walk state. It requires parameters as well as a player. The player is Tashio, so that we can decide based on the entity compared to Tashio's location which way we need to track, and we're only changing the direction field, which direction is actually what's updating our position over there. So that's process AI is just tracking the player, assigning a direction to go towards the player, and then we need to render. So all we do to render is pull the animation. Yeah, we don't need that. But all we're doing to render is saying, go grab our current animation and render from the frame, from the global texture, our animation texture, and then at the quad of the texture's G frames at index, whatever the current frame is. And then the animations handles what that current frame is, and we render it at the entity's location, which is updated by the direction. So this should work. So this is Boar walk state. We need to import this. So we have a gecko walk state that we're importing, right? So we need a Boar walk state right here. We should have a Boar, whatever, gecko walk state. We need a Boar walk state here that we're pulling in from our entity folder, Boar walk state. Let's just see if we crash. We do Boar walk state. Then on self on 21, let's see where that is. On 21, self, if self.entity.type is equal to Boar. Okay. We got our Boar. Look at him go, man. Look at him go. Oh, his little butt, man. Oh, he's so cool. Yes. Okay, he's tracking. Let's make sure we're importing him right. In our declarations, we're saying Boar. Okay, we need Boar walk state right here. So Boar walk state is the Boar walk. So he's no longer, since we copied over the gecko walk state for the most part, he should have the same behavior. should track us. Yes. Yes, man. He didn't change back to idle. He don't have no damage flash. He isn't responsive to collisions. His render order layer's messed up. All in good fun, right? But dude, look at him chasing. It's so cute. It's good stuff. Okay, well, I say we make the Boar flea state placeholder, and then we can worry about fancy stuff after that. We might get rid of the create animations in the init right here. I think that's a good idea for right now. And this is also done the same way, right? We have the type, tack, flee, type, tack, walk, so that we can kind of dynamically change the state machine by its type. So as long as we stick to this naming convention, the logic works. So we will do this Boar flee state. We're importing it, or we're adding it as a state machine into the key of our state machine. So what we need to do is also put it here. So the Boar. Flee state. Okay, great. Boar flee state. We import it here. Now we need the flee state. We don't have it. So let's go make it. It's in our entity, and if we do this Boar flee state.lua, we can make it, and we remember how to do it. It's Boar flee state gets a class that includes base state. Now we need our three functions. We need our Boar flee state init function. We need our render, right? So we can say find colon, or what is that? Find render, and then we need an update, takes in delta time. So that's our flee state. It exists. Let's check out our gecko flee state just to see what we're missing. We do the same thing, right? We're gonna give ourselves a placeholder stuff. We know we need our entity, so that's what we pass in here. Just like our gecko flee state has an entity and a scene, so we're gonna give ourselves the scene. We don't even pull the scene, so it shouldn't be required. We need a process AI method, because basically we're saying in the map update, we're saying go ahead and process the AI of the current state machine. So if we don't have a process AI in a flee state like we do for a walk state, it'll try to process AI and it'll crash because it won't have this. So even if it's empty, we definitely need it. So let's just do this. Boar flee state's also going to have this process AI method, currently empty. Let's just do this, right, where we need what do we slow it down? We times it by 2.5, so we speed him up to walk away, kind of flees faster. But we shouldn't need this entity type checker. We shouldn't need this because the entity state machine should be limited to the type. But this is okay. All the update's doing is just giving us a direction, or it's saying, what do? We pull a walk speed, and then we modify our position by our walk speed scaled by 2.5. it's messy and it doesn't make a lot of sense, but right now we have it. Boar flea state. We don't do anything else other than render. So we should be okay to just render this boar flea state. All we're doing, pulling current animation, go ahead and draw it. That's all, literally all we're doing. We could put it like this. Yeah. It's whatever. Yeah, it's whatever. Okay, let's see if we crash. Let's see. Oh, yes. Look at him go, dude. He looks great. He looks great. I feel like he needs more. I feel like he needs to have more caboose when he's facing down. Am I right? You gotta have a thick old caboose. You really do. You really do. I don't think we'll work on that tonight, but we have the Boar state machine being made. We have the placeholder for all the AI and stuff, which is really good. And then we have... Where are we? It looks like we defined all the frames right, which is great. But we're doing... Where is it? Where we... Right here. Okay, so yeah, we give it the boar, and we give it the walk state and the flea state for the boar. Okay, I'm curious. Let's try to comment out this. And we'll comment out this. And we'll see, because I'm pretty sure it's unnecessary. Entity 123. Really? Entity 123. Okay, create animations. It needs a dot animations. It needs animations passed in. I guess we need it. I mean, can we just have it empty? No. Okay, well, we've got it working. Oh god, dude, what the Okay, here we go. We got it working. We got the basic state tracking, which is very cool, very cool. It isn't registering collisions with spell casting, but it's rendering our collisions. You know, it's hitting us, so that's very good. That's very good. Okay. Well, I am very tired. We will call it a night here. We will check out our get diff. What did we do? Well, we added a Boar instantiation into map 7.3. We gave it 3 different state machines, right? We imported those state machines, and then we added the logic for the updating of the positioning based on direction. So that's what gives us the moving boar. We will commit with a message saying add boar walk and flea state placeholders with animations working, which is great, and we'll push it. We'll call it a night. Let's run credits here and call it a night. You're kidding me. There we go. There we go. There we go. There we go. Okay. Well, thanks for watching, everybody. I'll be back tomorrow. We'll work on cleaning up the mess we did today, right? Which is, we needed more code than we thought, but there's some improvements to be made, right? With like the type checking on the state machine, we shouldn't have to care about that. We should know only boars get turned into the walk state, so we don't need to check the type field in the walk state. So that should be taken care of. And then we can work on better logic, right? We need to add collision and then better or different walk speed or different behavior. So it's a different, the boars in this game are going to kind of wait until you get a certain distance away, and then they're going to lock onto you, and then they're going to like chuff chuff and then charge you. That's my current plan for it. So we'll be adding that instead of the gecko AI tomorrow for the boars, because right now they're just doing the same gecko AI. Other than that, please like and subscribe if you liked it. If you want to follow along, you can wishlist and try the game demo at steam.tashio.dev. So if you want to support the channel, go ahead and give it a wishlist if you're interested in playing. Like the video if you found it cool or interesting, and I will be back tomorrow. Thanks for watching.